Hi everyone. Today we're going to take a look at day 3 of our statistics unit. We're going to do some more practice with calculating probabilities based on the normal curve and looking at z-scores. So I have a warm-up here for you that I'd like you to try first before we get started with the lesson. So please pause the video for a couple of minutes, read through the warm-up, and there are 3 questions for you to try. Okay, let's go over the warm-up. So for the question here, you were told that you're given a normal distribution of values for which the mean is 70 and the standard deviation is 4.5. And we're just asked to calculate a few things based on that. All answers being rounded to the nearest thousandth. So the first thing we're being asked to look at is the probability that a value is between 65 and 80 inclusive. So because this is data that's normally distributed, we are going to sketch ourselves a normal curve. So I'm just going to give myself a sketch here to work off of. And we know that the mean is 70, so I'm going to put my mean right in the middle. And they want me to find the probability, which is just the percent under the curve between 65 and 80. So 65 is a value to the left of 70, so I'm just going to indicate that, somewhere over here. And 80 would be somewhere over here. So what I'm looking for, just again, visually, this is what I want. But I don't have the curve in front of me, right? We're not working off of that standard normal curve anymore where we have half and full standard deviations above or below the mean, and those percentages are given to us. So this is where we need to use our calculator. So we're going to go to our calculator right now. And we're going to go to second vars. All right, and we're going to calculate that probability by going to choice 2, which is normal CDF, which is how we calculate that area under the curve. And since our lower and upper are given to us, because we are calculating between 65 and 80, my lower is going to be the 65, 80 is going to be my upper. This is the symbol the calculator gives you for your average, so that's my 70. And this is our symbol for standard deviation, and they told us that was 4.5. So now I'm going to paste this, going to hit enter, and my calculator should give me that probability. So you should have ended up with, we are rounding again to the nearest thousandth. So decimal, we had 0.85360.555. So we could round it. It did not say that you had to write this as a percent or a decimal. So if you left it as a decimal, nearest thousandth again would be 0.854. If you did round this to a percent, 85.36055%, then to round that to the nearest thousandth, it would be 0.361%. So either format is fine. If it was specifically asking you, for a decimal or percent version of the answer, it's usually not that specific. So just make sure you're rounding appropriately in whatever format you left your answer. Okay, second question. Same mean and standard deviation, but now we're being asked to calculate the probability that we have a value greater than 75. So again, the visual here, we're looking at a normal curve where the mean again is our 70. And now we're saying, okay, well, what's the probability? 75 would be somewhere off to the right of 70. And what's the probability the value is greater than that? So now I'm looking for the right side of 75 and above. So let's go back to our calculator. Okay, we're going to go back to second vars, choice 2. So our lower is our 75. That's the number to the left of our shaded in region. But to the right side of this, we don't have an upper, right? So you're just imagining that it's going on infinitely to infinity. But again, we don't have a symbol for that in the calculator, so I'm just going to type a really big number into my upper side. We don't have to change the average or the standard deviation because we're working within the same parameters. So I'm just going to paste that, and I'm going to get this value now of 0.11326. Let's come back to my notes. So again, you could leave that in decimal form. So we'll say 0.113, or if you changed this to a percent, 13.3 And then the full decimal. Before that was 1, 3. Oh, sorry about that, guys. Here, I had a mistake. So this was 0.133. And the decimal from the calculator was something like that. So again, either form of the answer is fine as long as it's rounded appropriately. Last part of the warm-up, the probability that a value is less than 62. So now we're just practicing what to do if we don't know a lower. So again, 70 is my average, 62 is somewhere off to the left, and I'm looking for the probability that a value is less than that. So last time here, let's go back to our calculator. Let's go to second VARS choice 2. Okay, so my lower is what I don't actually have a boundary for, so I'm just going to put in a really small number. Again, something that kind of is representing that negative infinity in a numerical value. The upper, well, we're looking for anything less than 62, so 62 was the upper value, and again, standard deviation and average are staying the same. Okay, so let's come back to the notes. We have a decimal here of 0.0377201, nearest thousandth, 3 decimal places. So 0.038 or 3.772%. Okay, so we just practiced how we are using our calculator to calculate what's going on underneath a normal curve, and now we're going to look back at what we started practicing yesterday, which was a z-score. Okay, so let's take a look at this question. We are told here that we have 2 versions of a standardized test given, an April and a May version. The statistics for the April version give us a mean of 480 and a standard deviation of 24. The statistics for the May version give us a mean of 510 and a standard deviation of 20. Okay, so they want us to assume the scores are normally distributed. For part A, Joanne is taking the April version and she scored in the interval of 510 to 540. Okay, what is the probability to the nearest 10,000th that a test paper selected at random from an April version scored in that same interval? So we need to know, okay, well, what's the area under the curve between her, her possible score range? So let's just get ourselves a visual again. So it's all normally distributed data since this is from a standardized test. And she took the April version. So let's just go back and look at everything from the April version. Had the mean of 480 and the standard deviation of 24. Okay, so my mean is 480. That's in the center of my curve. She scored from between a 510. So I'm just going to kind of give myself a spot up here. Between 510 and 540. All right, so we have 510, 540. And we're looking for this percent. So let's go to our calculator. Okay, we're doing the same thing we did earlier in the warm-up. So let's go second VARS, choice 2. Okay, our lower here is her 510. Our upper is her 540. Now our average score on the April version was a 480. And the standard deviation was a 24. Okay, so let's calculate that. So right in this part of my curve, 0.09944401. Just giving you the full calculator readout since I can't show both screens at the same exact time. So let's just round this. We'll put this in a percent. So we'll use the same rounding we did before. So 9.944%. Okay, so there's about, if I wanted to think of it in terms of a whole number, there's about a 10% chance that someone else could take this April version of the test and score in her same interval. That's what that 9.944% means. Okay, now for part B, it says Maria is going to take the May version. In what interval must Maria score to claim that she scored as well as Joanne? So that's what we spoke about yesterday. A z-score enables you to make comparisons. So even though they're not taking the same test, if I know what z-score her 510 and 540 were, so these z-scores, because this data is normally distributed, if I talk about, okay, let's use a different color even. So Maria's taking the May version, but since her data is also normally distributed, not the nicest looking curve, sorry guys. If I could figure out that same placement on the curve, I'm just giving you a visual to think about right now. I don't know the z-scores yet, but if I could find that same 9.944%, these scores will be different because she took a different version of the test with a different average and a different standard deviation, but I could get an interval that Maria would have to score in to claim that she did just as well as Joanne did. Okay, so now we have to do a couple of things. First, for the May version here, we are dealing with now a mean of 510. I'm just going to fill in what I have about May, and the standard deviation is 20. So before we go into the May version, let's go back and actually calculate the z-scores for Joanne's 510 to 540 interval. So when you want to calculate a z-score, the value is determined through the formula, right? So you take the actual score, which let's start with her 510. So you would take her score of 510 and you're going to subtract the average. So on the April version, the average was a 480. So this is giving me the z-score. Okay, and then you take that difference between the actual score and the average and you divide it by the standard deviation. And on the April version, the standard deviation was a 24. So if we did 510 minus 480 divided by 24, you're going to get 1.25. So now I know that that 510 had a z-score, I'll just add that in over here, that was a z-score of 1.25, which again just means it's 1 1/4 standard deviations above the average of 480. And now let's look at her other score of 540. So if I take again, 540 is the score minus the average of 480, and I divide that by the standard deviation of 24. In this case, you're going to get the value of 2.5. So this score, the 540, was 2.5 standard deviations above the mean. Okay, so now we know the exact interval based on z-scores of Joanne's scoring on the April version. And now what we're going to think about here is if, I'm just gonna get rid of these boxes because they're a little small. If I can figure out what score based on the May statistics would be either 1.25, let's see, 1.25 or 2.5. Again, these are just z-scores, not actual scores on the test. But if I could figure out what scores correlated to these z-scores, right, then I would know exactly what Maria has to score between to do as well as Joanne. So we can use this z-score formula again. So now I know the z-score, 1.25. I don't know the score she has to earn, but I know the average. That was a 510, right? So score minus average divided by standard deviation. Now her test had a different standard deviation. The May version standard deviation was a 20. Okay, so now if you want to cross multiply here, you're going to get x minus 510 is equal to 20 times 1.25 is going to get you 225. And then add 510 over. And you should get that score of 535. Okay, now we know the bottom of the interval. Now we have to calculate what the score at a 2.5 z-score is going to come out to be. So let's set that up. Okay, just do that side by side. So now I have 2.5. It's going to be equal to x, again, minus 510 over 20. So let's cross multiply. And now I'm doing 2.5 times 20, and I'm going to get 50. So if I add over the 510, I will get a score of 560. Okay, so now I know, if I go back here, just make my visual complete, she can score between a 535 to a 560, and that will put her into the same range as Joanne scored on that earlier version of the test. Okay, we're just going to look at one more question together. And this question also has to do with the curve, but not having the actual curve in front of you. So we're just going to look at this last question. Suppose you take an SAT score, and you take the SAT, and the scores of all students on that SAT have a normal distribution with a mean of 1020. Again, I just like to give myself a visual when I read through the question. Okay, so I'm at 1020, standard deviation of 153. What is the minimum score you would need to get in order to be in the top 10%? Okay, so I'm just going to draw a line over here. And if I'm in the top 10%, that would mean that this is 10%, right? So I don't know what score that would have to be. But what's interesting here is if we had the curve in front of us, and that maybe that number, that percent, was something I could get by adding some of those given percentages on the normal curve that we worked with on the first day, this question would not be difficult. But we don't have that in front of us. So there is actually one more thing in the calculator we can use to answer a question just like this. So I want you to go back to your calculator. Okay, and you're going to go to second VARS again, but we're going to actually go to choice 3. Okay, so what the calculator is asking us right now is what is the area, meaning the area under the curve. Now, I want to go over one calculator note. Some of us might not have all of the information you see right now on my calculator. So my calculator has this line that says tail, left, center, and right. So for those of you that have this option, we're going to leave it on left. And for those of you that don't have this option, your calculator only allows you to calculate it based on the left. So I'm just going to assume we're all doing it the same way. And what this is asking me for, I'm just going to come back here for a second. It wants to know the area to the left of the score you are trying to calculate. So we're trying to calculate this score. So we want this area. So if this is 10% to the right of this score, then this would have to be the remaining 90%, right? Since everything under the curve would add up to 100%. So that is going to be my area, the 90%. So I'm going to type in 0.9. Okay, and for this question, we were told that the average score was a 1020, so we'll type that in. Okay, and the standard deviation was 153. Now again, if you have this option, tail, leave it on left. If you don't have it, your calculator is assuming you're only basing it on the area to the left. And what this just did for us was it actually calculated that missing score. That 1,216, or the 1216, is the score. Sorry, let me get back here. That you would have to earn on this test to be in the top 10%, or the minimum score, right? Because if you didn't score at least this number, then you would not be in that top 10%. So inverse norm is a way that you can actually know the percent under the curve and let the calculator give you the score at that particular placement on the curve. It does not come up as much as the other ways we've used the calculator to find the percent under the curve, but it will come up in at least one of the practice questions, and it's just another way that you can use your calculator to work with data that is normally distributed. So now you're just going to work on the practice questions. You have just 3 questions on this next page to go through. I hope the video was helpful, and I will talk to you guys soon. Have a great rest